Okay, let's do this. Let's solve this problem first. I'll make a separate video. The next video will solve the second problem. So we've compressed this spring a distance of 12 centimeters. So presumably this distance here is 0.120 meters, right? So let's say that this is zero potential energy, so there's no MGH. It's not moving, so there's no 1FMV squared. There's no FS, because we're not going to do that. We're not going to use the spring. We're going to use the energy of the spring. But there is 1/2 kx squared, right? To begin with, and that's all we have, right? And then when it's raised itself to the highest point, it's going to have only MGH, okay? And that's going to be above our H will be this distance here, right? So when it has risen up and it is at the highest point, its velocity is 0, the spring no longer has energy, so all it has is just MGH, okay? And then the mass isn't going to cancel out of this, so we got to just plug it in. So 1/2 35.12 squared is, and then it's 140 grams, so 140 grams is 0.140 kilograms, right? 0.140. It's like a baseball, basically, right? A light, a fairly, not a wet baseball here. And then we don't know the height. So we can do this, right? So 0.5 times 35 times squared. The total energy it's got is 0.252 joules. And then I'm going to divide by 0.14, divide by 9.81. And I get that 0.183486 is H. So with 3 sig figs, we'd say 0.183 or 18.3 centimeters. All right. In the next video, I'll do the next part of the problem.